Constructing Mystery is a paper I originally wrote for the Atmosphere issue of JAE, and it attempts to unpack how we think about teaching with light as a material. When I think of an architectural atmosphere, light is a primary component that comes to mind. Atmosphere has within it the word atmos, which is the Greek for vapor. When light travels in air, it is invisible. Once it hits particles in the air, such as vapor, both the light and the particles become visible. We can see this in Anthony McCall's work that makes the space of projection visible. As McCall projects light curves through vapor, they become spatial, sculptural elements. We see light when it interacts with material. In order to create an atmosphere, architecture and light have to meet. They become intimately linked. Peter Zumthor writes, I don't understand light. It gives me a feeling there is something beyond me, something beyond all understanding. And I'm very grateful that there is such a thing. We think of light as a mysterious substance. We build and experiment with light, but many times we don't really consider ourselves experts on the one material that allows us to view the world. As an architecture educator for the last 15 years and a practitioner focusing on light, I've been developing a seminar to try to help future architects unfog this mystery of how light could be used as a precise, intuitive tool. The seminar is structured in 3 scaffold sections. The first section is in the format of a lecture that introduces light as a material and presents the innate link between light and drawing. The second section pairs theoretical lectures with physical light experiments, focusing on 4 topics in light. I chose camera obscura, shadow, reflection, and color to be those topics. We simultaneously studied the literary, philosophical, and contemporary arts stemming from each topic, parallel to students' hands-on tests with light and material. This allows us to create a literary foundation, along with developing an intuition to working with light as a material. In the third and final section, which is around half of the term, students construct a project that tests a thesis on projection using light. First, we ask, what is light? Light is defined as electromagnetic radiation visible to the human eye, meaning it's human-centric. As such, it is important to understand how we see. What is the structure of our vision? How do our eyes work? Understanding the physics of vision, optics, and the different technologies used to create light is a critical first step to addressing light from a position of knowledge. In the second lecture, we see how light and drawing have been linked since antiquity. Pliny the Elder grounds the origin of visual arts as the act of a Corinthian maiden tracing her lover's profile before leaving on a journey. This act requires a precise relationship between a light source, an object, and a picture plane. Robin Evans frames this act of projections through its representations as foundational to the 2 main forms of Western architectural representation: perspective, which is derived from a point source projection in light such as a candle, and orthogonal projection derived from parallel rays projecting, such as the shade cast by sun rays. Initially, the development of perspective was linked with a desire to understand how we see. Euclid first elaborated the discipline of optics in the 3rd century as a mean to understand the structure of reality. This link was severed by Alberti in the 15th century. In so doing, he freed perspective to become an independent instrument that allows us to precisely draw what we can see, but also what we can imagine. We can see this mechanism at work in Dürer's perspective machine that translates a 3D object onto a 2D plane, or in the reverse projection by quadrata fresco artists that use shadow or string to project a 2D surface onto 3D spaces. By studying cases and methods that demonstrate projective logics, students are able to contextualize their own studies within a broader inquiry. We may not be using string or candles, but the principles of projections remain consistent. After writing this paper, I actually decided to test and see if students can develop a mini lab, which this is one of the products of. The first original mini lab studies the camera obscura. It's a small move, a single aperture that changes the perception of a normative space through bringing the outside world in. The principles of the camera obscura have been known for millennia and have aided the development of scientific observation. Using camera obscura as a metaphor helped us visualize the structure of vision and thought, from Kepler and Descartes equating the eyes working to a dark chamber, to Locke and Leibniz using the camera obscura as a metaphor for human understanding itself. Parallel to learning about its history, students construct physical camera obscuras in different scales, from objects to full room investigations. They learn to both capture and reflect upon the outdoor images in a dark room, study their relationship to different apertures and the architectural canvases they were projected on. As the locations of the seminar changes, so do the results of the camera obscuras. From a campus quad projected onto a faculty office, to the piazzas and streets of Rome projected onto studio rooms in the medieval Palazzo Taverna. The second mini lab addresses shadows. In the allegory of the cave, Plato uses shadow to represent the stage that is furthest from the truth. A complete negation of light, which represents knowledge, shadow is cast as purely a negative condition. But a shadow is not merely an opposite or derivative. A shadow could also be understood as an independent entity, as we can see in this image. As in Pliny's myth, we look at shadow as a device for drawing. Students physically construct an artifact that casts specific shadows. We don't assume shadow is derivative, but strive to find specific conditions within it. We understand this shadow drawing as part of a projection machine that tests and impacts of different light sources and materials on the light drawings it creates. The third mini lab studies reflections. A reflection forms the image of a double. In a mirror, the double resides within the plane of the reflector, creating a virtual twin. In architecture, the reflected double plays a spatial role, reordering our perception of space. Here, the virtual double is the structure itself. As Robin Evans acknowledges, reflections become a tool to create coherence or destroy it. Similar to an Anish Kapoor reflector, the virtual is no longer a straightforward replica, but it reorganizes our spatial understanding. But the virtual doesn't always reside within the plane of the mirror. Sometimes it reflects light off of the mirror surface. My own light research studies how the double can operate as a transcription rather than a likeness, revealing surface reflector microtopographies as light drawings. Within this framework, students construct reflectors and test them under different lighting conditions to understand the mechanisms of optical reflection. They explore how reflectors could reveal aspects of the material world that would not otherwise be visible, uncovering a double they did not necessarily predict. The final lab deals with color, and usually is a shock to the students. Joseph Alvarez identifies that the clearest property of color is its relativity. He sees color as deceptive, since it continually changes based on its environment. Technically, we do not see objects. We only see light. When we do see color, we see the light reflected off of an object. This reflected light has the combined properties of the color of the object and the color of the light that illuminates it. The works RGB by the artist Karnofsky expose this mechanism, as they show how different lighting exposes radically different drawings. The students test color artifacts and see if color can redefine the perception of space. We test the same color construct under changing light, testing how the transforming conditions affect the perception of the object. In this lab, time plays a significant role. Hence, the sequence is essential. The last pedagogical step is developing a thesis about projection. Each student team expands on a concept from the course lectures and labs and explores it spatially in a one-to-one light installation. In many cases, this installation is a temporal performance in which light changes and hence transforms its environment. The seminar has evolved from semester to semester, and so has our relationship to the site for this final light installation. Beginning from an easily darkened review room in the School of Architecture, we transitioned to a black box immersive environment, a non-site with seamless surround screens designed as a virtual reality testing space. On the opposite end of the spectrum, we also tested a highly site-specific setting. In a study abroad program, we had the unique opportunity to create the final project and light installations in the Falconiere Crypt by Francesco Borromini in the Church of San Giovanni di Fiorentini in Rome. The project operated as a conversation between our light projection and the spatial Baroque architecture. Students cast shadow projections onto the architecture, in essence, drawing one-to-one drawings on the crypt walls. When the lights came up, we left no trace of our graffiti. When building atmospheres with light, we can operate from a position of knowledge. I'm not suggesting that knowledge negates experimentation or mystery. The components of the seminar were never meant to be illustrative devices, but serve as experimental and performative ones. Since the labs and final projects are not fully prescribed, students learn and discover as they test. And as the experiments gain precision, they have the potential to be calibrated as a more precise spatial tool. As the students present their light theses one by one, we all remained in the same physical space, but entered very different fictional worlds with different constructed realities. Thank you.